This is Josh Mandel with a quick primer on a new specification from IETF called Selective Disclosure JSON Web Token, and that's RFC 9901 if you're counting. And I want to give you a sense of where this fits into the world of healthcare data exchange, what new capabilities this could unlock, and show you a demonstration just to give you a concrete sense of how this all works. We'll get into the mechanics of the method, but I want to start off by saying we've done a lot of standards in the healthcare world that try to solve problems of helping patients share data with clinical providers. In some of those standards, it's really important to make those data verifiable, which is to say that the party who receives the data can tell that the patient hasn't changed the data or tampered with it in some way. But it's worth saying there's a lot of use cases in healthcare, probably the majority of use cases where verifiability is not a strict requirement. But that said, we do have examples where it matters quite a bit. And in the context of the pandemic response, that included being able to prove that you had received a certain vaccine. But this is also true for school registrations and sports and so forth. You might also see examples where you want to demonstrate that you had a negative lab test for an infectious disease or a sexually transmitted infection. You might want to prove that you have insurance coverage or that you've had certain drug screenings. And all these represent the minority of cases where you might not just want to take a patient's word because there's something specific at stake and you want some external evidence that backs up what the patient is representing. So there's a spectrum of use cases. Verifiability isn't always critical, but sometimes it's super helpful. And now we get into standards that enable this kind of verifiable sharing of health data or sharing clinical information that can be verified by the receiving party. And it's worth saying that with smart health cards, we achieved this, but there's always a balance between sharing data that's verifiable and the privacy. In other words, the choices that an individual has about exactly what gets shared. The way we dealt with that in smart health cards was to define what we called a set of minimal disclosure profiles, because the standard itself just provided a way to share the entire document or nothing at all. So we had to be very careful that the entire document was a reasonable and well-balanced set of information that was specifically tailored to a relatively small job of who is this person and what vaccine did they get. In other words, demonstrating that Josh Mandel, who was born on a certain date, received a certain vaccine dose at a certain time. Those are the kinds of data that went into a smart health card for verifiable vaccine records. And we were very careful to say things like my social security number and my home address and phone number should not be in that payload. And we achieved a pretty good balance through that kind of deliberative process, working with the ecosystem to define a good artifact that was tailor-made to this use case of verifying a vaccine history. And that was a really good and successful kind of compromise, and it allowed us to get implementations out into production very quickly. But it's worth saying that that kind of compromise and negotiation and consensus building on what is the right payload, that does not scale very well to a huge variety of use cases where you might have different parties who are asking for different data sets for different reasons. If the healthcare organizations who provide that data in the first place, who attach their signatures to the information, if they have to be involved in negotiating use case by use case, we never get to an ecosystem that can cover this broad set of use cases. And so this is where this new specification from IETF, Selective Disclosure JWT, comes into play. This provides us with a set of tools for allowing a healthcare organization to give the patient a whole bundle of data and allow the patient to selectively disclose or selectively redact exactly what they want to share in any given case. But the signature remains intact, and the verifying party can tell that the parts that are shared haven't been altered. And it works through a set of cryptographic techniques where ultimately you have to break down the payload into a set of individually disclosable facts. So you might say that the name is one fact, a date of birth is another fact, and each diagnosis is another fact. And to provide kind of a metaphor here, you can think about each of those facts as being sealed up in its own little locked box or its own little slice of a bigger locked box. And all that set of facts gets handed together along with a signature to the patient. And when they want to present it, they can choose which envelopes to reveal the contents of in that box and which envelopes to retain in a locked fashion. And so when they present this to a verifying party, they can disclose whichever subset of these facts they choose. That's the basic pattern, and it's protected by a set of cryptographic primitives that ensure that the verifying party can't guess what was inside these locked envelopes, but can verify that the contents that are in the unsealed envelopes reflect exactly what the issuer packaged up at the beginning. And the main insight here is that this allows the holder, the patient, the person in the middle of this exchange to decide what gets shared for what use cases. And that's really powerful. And I want to show you a quick example of how that works with FHIR. So when you've got a detailed data model like FHIR that has all these nested, repeating, complex data structures, it would be pretty overwhelming if you said that every last attribute of the entire JSON structure was individually selectively disclosable. You might even get into situations where somebody was disclosing a nonsensical subset of the information, or where hiding certain attributes made it impossible to correctly interpret the pieces that you were sharing. And so I've developed a set of profiles for doing selective disclosure JWT with FHIR, and I have that hosted on a demo at joshuamandel.com. This is the FHIR Redaction Studio. And on the left-hand side, we've got a FHIR bundle. And on the right-hand side, we've got a selective disclosure JSON artifact. And just to give you a sense of what we're starting from, if I wanted to share the whole bundle, I would copy this whole artifact, and I could paste it into a debugging tool like this one at SD-JWT.co. I don't know anything about the provenance behind this tool. I wouldn't necessarily put real protected health information inside of it, but it's fine for demo data. And what you can see here is what I've actually shared when I paste that SD-JWT in, is I shared the scaffold, the outline, the superstructure of a FHIR bundle, but each of the entries in this bundle has been blinded or obscured with this kind of random unguessable string here. And this represents a hashed value. And as a patient, I am given each of the pre-images for all of those hashes. So I know the name of the patient record is Alice J. Smart, and I know the email address is alice@example.com. Every little piece of information is in its own disclosure box, and I can decide which ones to share. So in this case, I've shared all of them, and so the bundle that comes out on the other side has the full structure and all of the properties that were in the original FHIR payload. But now is the fun part. I can come in here and say, maybe I don't want to share my social security number. I'm okay sharing my medical record number, but my social security number, I don't like that one. So I'm going to cross it off with this permanent marker here. And in case you can't appreciate the full glory of this cursor icon, it's a permanent marker that is also a fire extinguisher with the FHIR logo on it, just to mix a whole bunch of metaphors here. But this is the tool that I can use to cross off various attributes of the payload. And if I scroll down here, you can see when I leave this social security number in, then the reconstructed payload has it. But if I cross it out, then I've created a presentation, a selective disclosure package that omits that identifier. And I can go on through this overall payload and I say, I don't need to share my home address or my work address. And so now I have no address array in the patient record. Maybe I just was going to share work, and then the address array reappears. So you can do disclosure at the data element level, or I should say the FHIR data type level, whether that's a complex data type or whether it's a primitive data type. You can also do it at the resource level. So maybe I don't want to share this clinical condition of type 2 diabetes at all. I just cross it off and it disappears from the output bundle. Maybe for this use case, I don't need to be able to share my body weight. It's just not relevant. So I'm not going to share that. So you can think about building up the payload that you do want to share or crossing out the details that you don't want to share. In general, you would never put this kind of interface in front of a real patient. You would give them a much higher level set of decisions, and the crossing out and redaction would happen through an automated engine. But a mechanical demo like this shows you exactly what's happening under the hood, so it can be very powerful for building that kind of mental model. And I do want to say the profiles that I created here understand a fair amount of FHIR semantics. So they know, for example, that vaccine code is an optional element on a vaccine record, and it's possible to redact it. On the other hand, the status, not only is it a required element, but it's marked as a modifier element in the FHIR specification. And what that means is that if you don't know the status of an immunization, if somebody omits the status when they're sharing an immunization with you, then you can't correctly interpret the immunization. And the reason for that is these status codes include things like completed, but also things like was not performed or not completed. And if you see an immunization record and you know exactly what immunization we're talking about here, which is a COVID vaccine, but you don't know whether it was given or not given because that status is missing, now it's unsafe to interpret that record. So we try to use FHIR semantics here, and we label as selectively disclosable data elements that are not considered modifiers in the FHIR specification, and then we allow those details to be redacted. So maybe I want to be able to say that I received this vaccine on a certain date, but I don't need to tell you that I got it at the free clinic at this particular address. So I can create a selective disclosure that just gets across the information that's needed for the use case. And just to sort of see what's happening here, this is the artifact that would be copied and pasted or shared with the receiving party. And the more things that I cross out of the source payload here, the smaller that artifact is going to get. You can see this scroll bar here is shrinking a little bit as I redact more and more of this payload. And ultimately, I can show you what that's going to look like when I copy this into the selective disclosure tool here. And now there's only a few disclosures that I've chosen to make. And then the reconstructed bundle is much smaller. But critically, I can verify that this reconstructed bundle is correctly signed by the public key of our issuer. And if you want to play with what's going on here, you can try out the redaction studio for yourself, or in GitHub, there's a folder of the data that's sitting behind the redaction studio, so you can see the public key and even the private key that was used to construct the selective disclosure JSON Web Token in that demo. You can try it out for yourself, or you can open up the demo settings screen and try your own FHIR bundle and try your own signing key on that to create artifacts, just like the ones that you see inside the demo itself. So this is a view of where selective disclosure JSON Web Tokens really changed the game in terms of giving patients a set of data upfront and letting them or their preferred apps and tools select what to disclose downstream. And this is powerful because you no longer need consensus or agreement with every EHR and every clinical provider about all the different use cases for sharing verifiable information. But when it comes time to share data, you can share it in a verifiable or non-verifiable way according to the use case and your needs, and you don't have to overshare. We avoid this all or nothing dynamic. So hopefully that's an interesting tour, hopefully enough to get folks thinking about the potential for this technology, and it'll be really interesting to think about where this might fit in a future version of the smart health cards specification.